Okay, so what I want to do today is just, again, some review, basically. First, what I want to do is I want to go through, wrong button. So I pressed the wrong button on my slides. Here we go. What I want to do first is just do a few more examples. Okay, so this one's from the book. They tell you, basically you want to be able to take out, withdraw, that is, $30,000 each year for 25 years, from retirement, let's say, okay? And we know the retirement account earns 8% interest. I think the wording in the book might be a little bit better, but hopefully from here you can see what the problem is. So they want to know, how much do you have to have in your retirement account to accomplish all this? So again, you want to be able, when you retire, to withdraw $30,000 every year for 25 years. And it turns out the account earns 8% interest. Okay? So these parts here I added. The question in the book is, how much do you need to have in your account when you retire? And basically what I said here from B and C is, how much total money are you going to pull out after 25 years? So after 25 years, let's say, how much money would you have taken out, in other words? And how much of that money was interest? That's what basically part C was saying. So, okay, so let's get started on that. Okay, so here again, what we want to do is we want to work with some of the formulas we saw earlier. Okay, we want to use the formulas. This is, remember, we're making multiple withdrawals. So this is actually a payout annuity. Now that's what this is, a payout annuity. Okay. And remember, we're assuming, we saw some examples last time. That's why I said, just like in the previous example, we are assuming, remember, that unless stated otherwise, the number of compounding periods in a year equals the number of withdrawals you make each year, or deposits each year. So in this case, notice we want to know how much we need in the account when we retire, right? This is a payout annuity, so we're looking for how much we should have in the account, the balance that is, in the beginning. That's what P0 is, okay? This is what P0 is. That's what we want to know, because that's the account balance in the beginning. So again, the idea is, when we retire, okay, we want to know how much we should have in our account at the beginning when we retire. We're withdrawing regularly $30,000, okay? $30,000 we're withdrawing regularly. Once a year, that is, right? So that's what PMT is, $30,000. I mean, you could use the TVM solver to solve these. The impression I got was that most people didn't like using it. So I figured it'd be good to do these kinds of questions with the formulas. I mean, I did that in lecture, but I thought it'd be good to do it now with the formulas as well. The annual interest rate, right? Well, we have 8%. For the formulas, you have to convert it to a decimal, like this, 0.08. That's what you have to convert it to. And what's the number of compounding periods? Wait, someone have a question?
Hi, I'm slightly confused. For this one, we're using the annuity formula, but
the payout annuity formula, yeah. The payout annuities.
Okay, so then if it wasn't like withdrawal or payout and it was just like straight up deposit, would we just use the regular compounding formula?
If it was multiple deposits, then you would use an annuity formula.
Okay, thank you.
Okay. On the note, no, that's a very good question. I think on the notes last time I wrote down also when you have which, if you're doing multiple deposits, actually, let me get those notes. I think I might have them. I think I should have them. I think this is it. Let me just see if I can get to it. That's this. No, wait. Oh. I mean, you found the notes from last time, so let me just double check. And I did post the notes as well, so come on, where is it? Wait, here it is, here it is. Let me just share this quickly. That's a good question. This one, here we go. But you'll see right now. Here it comes. See, so when you have one deposit, that's when you just have compound interest. An annuity is many deposits, but we have a payout annuity. So there's many withdrawals. That also determines what formula you use. That also determines the formula. So if in this case, our formula is going to be this. You know, we did do this last time as well. So I hope that helps, actually. So again, these notes, I think, I did post these notes today, actually. So you do have those notes.
Thank you.
You're welcome. Awesome question. Any other questions? Here we go. Okay. So again, basically now we have we have the variables in this problem, okay? Okay. Again, since we're withdrawing only once a year, we're assuming that the number of compounding periods is only once a year. The number of compounding periods is always equal to the number of withdrawals or deposits each year. So in this case, we're withdrawing only once a year. So n in this case is 1. There's only one compounding period in the year. This is happening for 25 years. So we use our formula. I did email the notes, so everyone should have these. So we have $30,000, right? That's the PMT, right? That's our regular withdrawal. R is our interest rate as a decimal. We said N is 1. T is 25. Okay. And the way we solve this, you really want to handle the top and the bottom separately. So if we do the bottom first, that's actually pretty easy. We just have 0.08 over 1, so that's just 0.08. For the top, okay, what do? Well, we want to work with the innermost parentheses first. You know, pen this in other words. That's what we want to do first. Okay, so we have 1 plus 0.08, right? 0.08 over 1, excuse me, is 0.08. 1 plus that, that's what we do next. We also did the exponent. It's negative 1 times 25 is negative 25. So again, 1 plus 0.08 is 0.08. Okay. Now 1.08 to the negative 25, that's where you want to use a calculator. I mean, I definitely cannot do that in my head. So from here, we have this. From here, we have this, okay? So what we have then is, you know, this 1.08 to the negative 25 is equal to this here. And then we do 1 minus that. That's how we get here. Now, remember, we're doing parentheses first. Now we multiply and divide. All together, we're going to get this. Okay. Notice also that I rounded to 2 decimal places. On the exam, I'll tell you how many to round to. In our intermediate, well, here, in our intermediate calculations, I'm using more than 2. In fact, it looks like I'm using 7 decimal places. 6 or 7 is good to use. I mean, theoretically, the more you use, the more accurate your answer is going to be. And this is money, so in the end, we're rounding to 2 decimal places. So this is saying the amount in the account that we need to have when we retire is this amount. Okay, so really, so we have that. And parts B and C actually I added. So this is a problem in the book. But B and C I actually did add. B is saying how much total money will you pull out of the account. So in other words, if you're doing this, right, withdrawing $30,000 from that account for 25 years each year, how much do you take out altogether is what we're saying. Well, how do we get that? We just multiply, right? It's $30,000 per year times 25 years. And that's equal to this amount. So again, okay, this is how much we end up taking out altogether. And now the next question I'm asking is, how much money here came from interest? How much money, not here, excuse me, how much money came from the interest, okay, in this question? How much in the account is from interest, okay? Well, we have our balance. This is how much we're taking out, right? Well, anything left over is our interest. So we have $750,000. That's how much we're taking out. This is how much was in initially. So anything left over in the account came from interest, which is what this is. I mean, I'll be honest, parts B and C I actually added. I thought they would be really good for this question. I mean, C, I guess I probably could have worded a little bit better. So, but it does come from the book, though. The first part, that is. Part A that we answered already. Okay. All right. Let me just pause the recording. Any questions on that?